Hi team, Mr. Rator here. Continue with higher unit 3, question 10. Okay, let's have a quick read. The group frequency table gives information about the heights of 30 students. Okay, write down the model class interval. Again, look for the highest frequency. Now it's not 10, that is the highest frequency, but the model class interval is this. It's H, which is less than or equal to 170, so height which is less than or equal to 170 but greater than 160. So that's what you should write on the dotted line. Okay, let's just clear this. Let's scroll down a bit. What is it asking us? Now, in the second part, it said this is an incorrect frequency polygon. This is the incorrect frequency polygon drawn from the information in the table above. So let's see, there's the table above. Let's see what they've done. Now straight away, this is wrong here. You do not connect the starting point and the end point. So this line should not be there. And straight away what you can notice is they've plotted the points at the beginning points here. They plotted it against the beginning points. When you do a frequency polygon, this should be plotted in the midpoint, in the middle of this. This should be plotted at 135. This point should have been plotted at 145. This should have been plotted at 155. Okay. Sometimes they do tables wrong. I'm just going to check if they put anything else out here. So that's going up okay. 2, 4, 6, 8, 10, 12. That's fine. 30, 40, 50, 160, 170. Yeah, the rest is fine and it's been labeled correctly, so everything is okay. So those are the two main errors. So if we was to write those down, we would say write two things wrong with this incorrect frequency polygon. What's wrong? They have connected the start point to the end point. So two things which is wrong. They have connected the start point to the end point, so this is wrong. And number two, what's wrong is that they should have used the midpoint for the height. They should have used the midpoint for the height. Okay, so yeah, I'll use those two. Let's keep it simple. Let's clear this. Let's move further down to question 11. Let's have a quick read of this. A car company records the number of miles of different engine sizes in litres traveled using 1 gallon of fuel. Scatter diagram shows information. So this is the number of miles, this is the engine size, and as you can see, the bigger the engine size, the less miles it does. The smaller engine size, the more miles. Okay, so that shows a negative correlation. Let's draw down. What is it asking us? Another car has an engine size of 1.8 and travels 42 miles using 1 gallon of fuel. Plot this information on the stack diagram. Okay, let's do that. So engine size is 1.8 and it uses 42. So that's about here. Okay, That's reasonable. What type of correlation does this active graph show? It shows a negative correlation. Draw the line of best fit. If I was to draw a line of best fit using a ruler, actually, let's use this line. If we go from here to here, use a straight line going here to here, that will be my line of best fit. Oops, it's moved it a bit. So let's go from there and grab that about here. Yeah, I'm happy with that. Okay, so once we've drawn the line of best fit, it goes here. A car has an engine size of 2.8 litres. Find an estimate for the number of miles the car travels on 1 gallon of fuel. So if we use this one, liters 2.8 is about here. We should use a ruler going along here, dot to up to this point, 2.8. If we went along here, we estimate, it goes estimate the number of miles to travel. This will be about 32. If we was to estimate 32 miles you would expect it to travel. Okay, let's scroll down, clear all this. Right, I think this is our last question. Okay, so here, scatter diagram shows information about 10 students. For each student, it shows the number of hours spent in revising, the marks student achieved in the Spanish test. So this is showing a positive correlation, as the more hours spent revising, results in a higher mark in the test. Okay, a higher mark. So one of the points is an outlier, right then, which is an outlier. So one of the points that does not sit along on this line is this person here. Okay, so right then coordinates, this is along the corridor 4 and up 10. So if I was to write that down, you go coordinates, I'll write it below here, so it will scroll up in a second. So 4, 10 is an outlier. Let's just scroll down here. What have we got? So that will be there. Let's just clear this one. So that's 4, 10. So the next two questions. For all the other points, draw the line of best. For all the other points, draw the line of best fit. Describe the correlation. Well, we said it's a positive correlation, and we'll draw a line of best fit in a second. And from the line of best fit, the student studies 9 hours. Estimate the mark gained by the students. So let's just do that again. If we draw the line of best fit, use the ruler for this. I'm just gonna careful. Use the ruler. The line of best fit. Person studying 9 hours. Go up in a steady straight line and go along here. The mark the student will be expected to get is about 65 approximately. So 65 marks. 65 marks. So person studying 9 hours. 9 hours approximately achieves 65 marks. There will be some error interval where you've been given some marks, so don't worry about that. And we said it represents a positive correlation. Okay, so the more you study, the higher the mark you're going to get. Okay, let's just clear that. I think we got one last question at the end. Let's just quickly see what it says. The Spanish test has been marked out of 100. Lucy says, I can see from the graph that had I revised for 18 hours, I would have got 4 marks. Comment on this. Well, what you gotta realize is the data is only between 2 and about 14 hours. Now 18 hours is, we call that extrapolation. Okay, you're estimating something which data we haven't tested for. So what you need to say is, the comment will be as we are extrapolating this would be a poor estimation. Or if you want to put it another way, 18 hours is outside our tested range, so we don't know if the relationship would continue beyond our tested data.